Hello, class. Welcome to week 3. This week we're going to be talking about mountain building and earthquakes, which the homework and the labs are going to be on earthquakes, but mountain building is also going to be on the exams, of course. But it's also a really fascinating subject and definitely relevant for us in our part of the world. And I felt like the videos go over portions of mountain building and don't quite explain everything. Luckily, in our section on volcanology and igneous rocks, we're going to be talking about how magma evolves. And it's primarily the difference between your oceanic crust and your continental crust. Like, how do we get from oceanic crust to continental crust? And there's a lot of ways that the Earth works on rock to change it such that it's sort of, it changes from that denser mafic material to get to that lighter, less dense continental material. And that's really important for the stages of mountain building because within the Earth system, especially over time, that solid rock can still act, as we call it, plastically, and therefore lighter material can it has buoyancy, it actually rises up. Or another way of thinking of it is that the more dense material pushes itself underneath that light material and pushes it up. And this is essentially how we get our mountains, at least in most cases. In all cases, mountains form when you get land that rises up relatively high compared to everything else around it and is in this constant state of equilibrium between being eroded away and lifted up. That's why, as the video you'll watch this week explains, some mountains, especially the oldest ones, the material you see at the surface has been buried underneath the ground for millions of years. And so you can get some really old rock coming to the surface. And the first kind of mountain chains that we'll talk about are folded mountains, as you see here on this little diagram. That's when when there's a continent-continent collision, and that tectonic force squishes that rock together, folds and bends and creases that material up. And this is how we get some of the largest, most stunning mountain ranges in the world, like the Himalayas or the Alps, or in our neck of the woods, the Coastal Range is from this continent-continent collision. And that's to say that section of land west of the Coastal Range used to be out at sea until tectonic forces moved that material and docked it or adhered it to the side of our continent. Now there's also the Cascade Range, and the Cascade Range, as most of you know, is made of volcanic material. It's built up from volcanic activity from that downgoing slab where some of that material turns into magma and comes up through the continental crust to make a volcanic range of mountains. Fault block mountains can occur, as with most mountains, typically the most tectonic activity is around the outside of the continent. The internal craton is more stable, and so usually you don't get fold mountains or volcanic mountains. But sometimes within a relatively stable area, there still might be some of these tectonic forces from the outside causing fault blocking. And in the Basin and Range area in the American Southwest, you'll see fault block mountains where there's either extension of the crust, and so these blocks sort of fall, and these faults create relief within the topography, and so the block of land that is lifted up then becomes a mountain. And in Oregon, the Steen Mountains are this type of mountain. And these can be a great subject of your field trip if you wanted to go out and take a look at any of the mountains within our little neck of the woods and talk about them in this tectonic setting. So moving on to earthquakes, there is an additional reading this week. It's called The Really Big One, and it highlights what I think many people in the Pacific Northwest by now have read. It's a New York Times article, and it talks about how in our neck of the woods, with that downgoing tectonic plate and the way that it scrapes against our continental material, is primed to create massive earthquakes like the kind we see in Japan, not like the kind we see in California. And it highlights just some of the reasons why it could be really bad in our neck of the woods. And that's because whereas the earthquake activity over in Japan and other places in the world where these sorts of earthquakes occur, they have a long history of that. Whereas we as Westerners only settled this area recently, and one of those large earthquakes has not happened within the history of white settlers. And so a lot of our infrastructure, a lot of our buildings are not built to cope with that. And so the big one could be really bad. And that's why with the homework and labs, we are looking at earthquake preparedness and kind of just thinking about some of the things that you might encounter if there were ever the really big one. You know, we could go generations or hundreds of years before another one comes up. But there are definitely indications that we should be concerned about it. Okay, so next up, the exams are going to be starting in week 4, well, exam 1. And so here we have a practice test for you. It's going to have just like 12 random questions. Each time you do it, you can do it as many times as you want. And that's going to give you great practice for that. It's going to draw 2 questions from each video. And there's also a review quiz for this week and a special discussion forum specifically for exam 1 questions instead of going with the student-to-student help forum. Once you take the exam, these will no longer be available to you. It's one reason why this is its own forum. But when you do post in the exam 1 discussion, you might ask particular questions, or you might ask questions regarding some of these practice questions. And when you do so, please make one post about one question and provide as much information or thought about that question as possible so that the answer can be more specific and satisfying to you. If you do plan to take a test at the LCC testing facilities, you're fine. All you need to do is go in and next week there will be a link for you to click and it will say LCC testing facility exam. And below that will be a non-LCC testing facility exam link. For those of you that aren't planning to come into an LCC testing facility, you'll need to find a testing facility near you, give them the information about like when you would like to take that test, and give them my contact information. They'll contact me, and I will send them a password so that when you click on that non-LCC link, they will enter the password in, and that will allow you to use whatever computer that they're using. Otherwise, it'll be blocked. You can find that information for finding a testing facility in the syllabus. And if you go down to exams, it's going to be right here. And these are testing facilities that are within our network, so to speak. One final thing I figured I'd mention, which is not really a big deal, but some of you were mentioning that the labs were showing up for you, even though you weren't signed up for the lab course. Well, that's my fault. I didn't code it right. And so now, if you are taking the lab course, the 4-credit course, you should see these. And if you are not taking the 4-credit course, if you're taking it for 3 credits, these should be invisible. So it'll just be kind of out of sight, out of mind. You won't have to worry about it. Okay, so that is week 3 for now. Feel free to send me any questions you might have, and good luck on this week.